Hello, good morning student. Myself Veena, Assistant Professor, Department of Mathematics, Government Science College, Bangalore. In this session, let us study about derivative of function of the complex variable. Derivative of the function of complex variable or differentiability of the functions of complex variable. So, let W is equal to f of z be a function of the complex variable defined in a domain D. Then f of z is said to be differentiable at a point z0 belongs to D if limit of f of z minus f of z0 divided by z minus z0 as z tends to z0, that is equal to f dash z0 exists, it must be exists at any point z, or it is also denoted by dw by dz is equal to f dash z, that is equal to limit of f of z plus delta z minus f of z divided by delta z as delta z tends to 0. So this is the definition of differentiability. So continuity is a necessary but not next theorem. In last class we have studied about continuity of a complex variable. So continuity is a necessary but not a sufficient condition for the existence of differentiability. That means differentiable, if a function f of z is differentiable at z equal to z0, then f of z is continuous also. But if it is continuous means it is not necessarily differentiable. That is, continuity is not necessarily differentiability, but differentiability implies that continuity. So this is the theorem. Let us prove this theorem. Proof, that is, if a function is differentiable means it is necessarily continuous. If a function is continuous means not necessarily differentiable. Let f of z be differentiable at z equals to z0. Then limit of f of z minus f of z0 divided by z minus z0 and z tends to z0. This is the definition of differentiability. Exist and unique, and it is equals to f dash z0. That is, f dash z0 is equal to limit of f of z minus f of z0 divided by z minus z0 and z tends to z0. Now consider f of z minus f of z0, that is equals to f of z minus f of z0, that is multiply and divided by z minus z0. Multiply and divided by z minus z0 when if z is not equals to z0. Now taking limit on both sides, as z tends to z0, we get limit of f of z minus f of z0 as z tends to z0 is equal to limit of as z tends to z0 z minus z0 into f of z minus f of z naught divided by z minus z naught, or this is equal to limit as z tends to z naught z minus z naught into limit as z tends to z naught f of z minus f of z naught divided by z minus z naught. But this is equal to 0 into this is f dash z naught, or this is equal to 0. Therefore, limit of f of z as z tends to z naught is equal to f of z naught. Hence, this is definition of continuous function, that is f of z is continuous at z equals to z naught. So, converse part, if it is continuous function, then it not necessarily implies that it is differentiability. We explain this by taking one example, that is conversely w is equal to f of z, that is given by a function z bar. So, delta w by delta z is equal to z f, w is equal to z bar, delta w is equal to z plus delta z bar minus z bar whole divided by delta z. But this is nothing but z is x plus iy. So, but here bar is there, that is x plus delta x minus I into y plus delta y, because z bar is x minus iy. So, minus x minus iy whole divided by delta x plus I delta y, because delta z is equal to delta x plus I delta y. Delta z be on real axis. Suppose it is on the real axis, that is delta y is equal to 0. Real axis means delta y is equal to 0 implies that delta x tends to 0. As delta z tends to 0, delta y is equal to 0, that means delta x tends to 0. Therefore, limit as delta x tends to 0, delta w by delta z is equal to limit as delta x tends to 0, x plus delta x minus delta y is 0. Since delta y is 0, minus iy minus x plus iy whole divided by delta x, since delta y is 0. Minus iy plus iy get cancels, x minus x get cancels. So, limit as delta x tends to 0, delta x divided by delta x, that is equal to 1. Next, when delta z be on imaginary axis, that is delta y tends to 0 implies that delta x is equal to 0. So, limits as delta w by delta z as delta y tends to 0 is equal to limit as delta y tends to 0. This becomes x minus iy minus I delta y minus x plus iy, because delta x is equal to 0. So, I delta y get cancels, remains limit as delta y tends to 0 minus I delta y divided by plus I delta y is equal to minus 1. So, therefore, along real axis it is plus 1, along imaginary axis minus 1. It is not unique value, therefore w is equal to z bar is not differentiable, since although it is a continuous, but it is not differentiable at any point. Okay. Next, let us solve one example. Using the definition of derivation, definition of the derivative of f of z. Find the derivative of f of z, that is z cube minus 2z at z equal to z naught by using definition of derivative. So by the definition, the derivative at z equal to z naught is given by f dash z naught is equal to limit f of z naught plus delta z minus f of z naught divided by delta z. Okay, if you take here also delta z, at delta z tends to 0, or that is equal to, now we know the function f of z. In place of z you have to put z naught plus delta z here, and here z naught, that is equal to z naught plus delta z whole cube minus 2 into z naught plus delta z minus f of z naught, that is z naught cube minus 2z naught whole divided by delta z, or that is equal to a plus b whole cube form z naught cube plus delta z whole cube plus 3z naught square delta z plus 3z naught delta z whole square minus 2z naught minus 2 delta z minus z naught cube plus 2z naught. Therefore plus minus this is get cancels, remains delta z cube plus 3z naught square delta z plus 3z naught delta z whole square minus 2 delta z divided by delta z. Here also divided by delta z, as limit delta z tends to 0. So that is equal to, delta z is common in all 4 terms, therefore limit as delta z tends to 0, delta z square plus 3z naught square plus 3z naught delta z minus 2 whole divided by, here there is no term because delta z will get cancelled, as delta tends to 0, this tends to 0 and this tends to 0, remains 3z naught square minus 2 is the answer. Okay, so this is the derivative of the function by using definitions. So we can solve some more examples by using the definitions. We will stop here. Analytic function in the next class. Thank you.